Hi there. Today I'm going to show you how to do the analysis in Star CCM. It's a CFD, Computational Fluid Dynamics Analysis. And this is the second in the series of how to convert from a 3D scanner model into an IGES file. And then finally, what we're doing today is importing that IGES model as a surface mesh to analyze it with different forces like airflow and velocity, pressure, downforce, drag, that sort of stuff. So to start off, I've gone up here to start a new simulation. Now, if you're on campus, you can just choose the defaults. If you're using the educational license at home, you'll have to provide your own power on demand license key, which I've already submitted. And then we're going to go up here to File, Import, and Import Surface Mesh. And this is where we find our IGES file here. Click Open. And defaults are fine for creating a new part, so I'm going to click OK. Now, as far as the tool menu goes up here, you have your basic file open over here on the left. You have macro automation if you wanted to record all the monotonous tasks that I'm about to show you to prep your model for analysis. We have our surface meshing generation tools here. Sort of our view windows, our initializing and running solutions. This one's a good one to point out is the mixed scene transparent, so you can see inside the model just like that. And we have some measuring tools here, and we have some animation tools for playing back our analysis that's been run so we can show other people in sort of video format. So what I'm going to do, now that we've imported this, I'm going to explain why this model is contained within this box. So now when I've created the Catia model, what I did was I imported the model. We created the surfaces. And then as a final step, I just created a box, an extruded box over this model. And you can do it a couple different ways. You can either extract the surfaces and treat them as surfaces within Catia, or you can just leave the box alone as an extruded form, and we can deal with it in Star CCM. Either way is fine. But the ultimate goal here is to separate these different faces on the box. Now, if I click on it, it's all one piece. The goal here is to separate each face from this box so that we can treat it differently. And you'll see in this model, the car is raised up quite a bit. It's actually in the middle of the box. Ideally, when you create your wind tunnel, you want to create, if you're doing a car, that is, you want it to be treating the floor of the wind tunnel as a road surface. So closer to the floor would be better. So what I'm going to do to separate these faces, I'm going to go into the part model over here in the tree. So I've clicked parts, and then there's the part model here. We have these different pieces of the car. And I'm actually, just for best practice sake, I'm going to select these, and I'm going to right click and combine. So now they're all one part, so I don't have to worry about them being separated. Now in this, I have one surface face here. What we want to do is split that up by right clicking and split by patch. What that does is allow us to select each individual face. Now these are just the part numbers for the faces. I'm actually just going to change this from face to inlet and click create. And then I'm going to rotate over here and click outlet and click create. Now we've defined those two. Now for computation analysis and sort of efficiency, I'm actually going to leave these as all one part. And I can rename those however I want. I'm just going to select them and rename them tunnel. And we'll actually see if that takes. It doesn't look like it took. But I'm going to rename them here. Okay. What I did was I just pressed F2 for rename. You can alternatively right click and go to rename here. So we have tunnel, inlet, outlet, perfect. And then we have our body up here of the car. So you can actually either go into surfaces here and rename each individual surface, or we can do that later on. I think it's easier to do it later on because we get the full name. So now that we've got that, we need to assign these pieces to what's called a region. Now regions we're able to assign functions and analysis to, and so that's sort of the process that we need to go through. So to do that, we can select our part here, right click, and go to assign parts to regions. I'm just gonna, those defaults are fine, but the important thing is to choose the create boundary for each part and switch it to create boundary for each part surface, so that we're able to manipulate the parts and choose different aspects for, or different things to analyze for different surfaces. So that is important. So we need to click apply, and you'll notice something appeared over here under regions. Let's see here, regions has been added, and we've seen that they added it to the boundaries here. So here's where I named inlet, outlet, tunnel, and the rest of the pieces here are the car body. So I'm just going to quickly go through here and rename it just for best practice, so we know that it has been changed and we know what we're dealing with. This looks like it's the body. This is the front right wing, or excuse me, front left wing. And this appears to be the front right wing. And this is the inlet, outlet, and tunnel. Okay, perfect. So we've got those renamed so we know what they are. So now what we need to do is we need to first generate a mesh of the object that we're dealing with. And so it's not just the car that we're dealing with, it's also the wind tunnel and the effects of the wind tunnel on the car. Specifically in this case would be the floor if the car was closer to the floor. Now if you're doing a model that doesn't require a wind tunnel, say for example some like a water pipes where you have a T-junction or something like that, where you have an inlet and two inlets and maybe an outlet, or two outlets and an inlet, that sort of, or even just a straight pipe. Your cylindrical walls of the pipe are going to act as your wind tunnel, just as I have here. One face is going to be the opening for your irrigation or sort of water pipe, and the outlet is going to be this face here. So if you think of it like that, think of this as a pipe. You have water or air rushing through this. That's how we're going to set this up so we can analyze the solution. So what we need to do is we need to go up here to Continua and right click and go to New Mesh Continuum. And we're going to right click Models and select the meshing models that we're dealing with. I found that Surface Remesher, Surface Wrapper, and Trimmer work well. So click Close. Now that those are chosen, what we need to do is go into this reference values for mesh. We need to change the base size of the mesh because it needs to be proportionate to the item that we're dealing with. Now this is a full-scale model of a car, of like a Formula car. If we chose the default base size, it'd be 1 meter, it wouldn't give us an accurate solution. So what we need to do is we need to do something like, let's say 50 millimeters instead. That's a good round number. Let's click Close. It's good because it's not tiny. The more accurate solution would be a smaller base size. If I had the computational resources, I would do something down to 1 millimeter. But for efficiency's sake and for general practice, if you're just doing a test trial and trying to get something to run, I wouldn't suggest choosing a really small base size until you know that the solution is going to run. And then once you have this the correct setup, you can change the base size to something much smaller. So we've changed it to 50 millimeters. Also something I found that helps is under wrapper scale. Let's double click that and let's do an 80% factor on that. Okay, so that looks good. We'll collapse this. Now what we need to do is to be able to generate a surface mesh. So we're going to click up here, generate surface mesh. And that's going to take a little bit of time to run. Generally on a complex object such as this, if I chose a really small base size, it could take anywhere up to, from 1 minute to 30 minutes to an hour, depending on the mesh size. That's what it's all dependent on. So I'll come back to you guys when the mesh has been generated. All right, so the surface mesh has finished. Now what we're going to do is we're going to go up here to right next to where we generated the surface mesh. We're going to actually generate a volume mesh now. So we're going to click that, and that's going to take a little bit of time, and I'll come back when that's done as well. All right, so now it's finished. And actually, both of those for this mesh size was actually pretty good. It took less than 5 minutes for the both of them. So that's extremely good. So now what we're going to do once we've generated that is we can actually view the mesh that is created. And you can view those options sorted down here in scenes. I'm going to right click. We're going to create a new scene and go to mesh. And this is going to show us the mesh that we've created here. Now, we don't want to really see the inlet or the outlet here. If you zoom in, you can see the mesh size. So this is 50 millimeters by 50 millimeters here. So what we want to do is we want to go under mesh scene here, displayers. This is the mesh we created, the parts that are associated with it, and you see your familiar regions here that have been imported. I'm actually going to right click the inlet and hide it, and right click the outlet and hide it, so you can see inside the model here. If you don't want to see the wind tunnel, you can easily just hide that as well just by going to hide. Just for reference sake, I like showing it to see where we're at. And so I can zoom in here, and you can see that 50 millimeters, maybe a little smaller would have been better, because you see some of these spaces here where there's a lot of curves involved might require more of an analysis. So we see how it has meshed, and it looks pretty good. So what we need to do next is we need to go up here and set the physical conditions, and just as before when we right clicked we went to mesh continuum, we want to go to physics continuum now. And you see our physics models here, and we're going to right click and select a model. And this has to deal with what we want to analyze, and we're going to analyze airflow. So what kind of airflow are we dealing with? We're dealing with three-dimensional. It's going to be steady airflow. The air is a gas. It's going to be segregated, and you can kind of play around with these here. There's not really a particular one that's really good, but I would choose maybe constant density, because it's going to be constant density airflow, and it's going to be turbulent. And so for the turbulence, one that we found that works well is the K epsilon turbulence. And you can choose anything else you want to deal with, gravity, radiation, electromagnetism, if you're analyzing other things here. But we're dealing with airflow, so we're good to go. So click close. Now what we're going to do is we're going to go into these initial conditions and set the actual pressure and velocity that we want to analyze. So for velocity, you can choose anything you want. I'm going to double click. And but it's important to note, let's see here in my model, let me click out of this. You'll see in the model that the x-axis is straight on into this model here. So that's important to note as we set the velocity. So if we want the airflow to go straight into this box, we need to set the airflow as a positive x value. So we have our x, y, and z coordinates here in meters per second. I'm just going to change this to, a pretty good airflow for something like this, say like 45 miles an hour. That's about 18 meters per second. Alternatively, we can change these units. I'm just going to leave them here. Click close. So that velocity is set. We're going to set the pressure here. If you have no idea what kind of pressure you're dealing with, what's nice is CDA Adapco has their program set up with reference values here. So I'm just going to go into reference pressure, copy this reference pressure here, and go back to constant pressure that we're going to set and paste that in. So this is just normal atmospheric pressure. Click close. So that's all set, so we can simplify this. And the other important thing that we need to do is under these regions, we need to choose the inlet. And this is how we tell that the inlet is the inlet and the outlet is the outlet. So to do that, I'm just going to double click, and it asked me for the type of thing it is, and it's set as a wall, but we're actually going to set it to a velocity inlet because that's where the air is coming from. That's what we've set our velocity as the constant 18 meters per second in the positive x direction. Now to the outlet, we're going to do the same thing, but we're going to choose, instead of wall, we're going to choose a pressure outlet. So any air that's remaining in there, the pressure is going to take care of it and take it out. That's how we create our in and out. So now what we're going to do is I'm going to show you, and I have it in geometry mode here. Let me open it up in mesh, and you can see it. So what we're going to do is we're going to add a streamline of the airflow over this car. So to do that, we have to, let me preface this by saying it's good to have sort of all your eggs in a row and have all of these settings actually set before you run the analysis, because sometimes the analysis can take quite a while, and so it's best to gather as much data as you can so you don't have to go back and rerun the solution. So I'm going to set up a new scene, right click, new scene, and then go to scalar, because it's a scalar field that we're going to analyze that velocity is. And so what I can either do is I can either right click this, or I can go into scalar scene here and displayers, and under scalar I can choose a scalar field, double click, and I'm going to choose under function, select function. I'm going to scroll down and I'm going to choose velocity, and we're going to analyze magnitude here. Click OK and close. So you see that velocity is shown up here. We can also change the point size of sort of the accuracy of what we want to analyze. What we also want to do is we also want to add the streamline as the outline of the displayer here. So let's see here. Under derived parts up here, I'm going to right click and go to new part, and I'm going to set streamline. Now alternatively, you can set a probe. That's for if you want to collect data over a specific point. Now with streamline, we want to collect data over a range of area. So let's see here, streamline, and then it already has the region set. So part seed is fine. I'm going to choose seed parts. And under regions, I'm going to select the inlet and outlet area, and that's where it's starting and ending. Click OK. And as far as resolution goes, I found that 10 is great. Vector field, it's already chosen as velocity, as I already chose that before. We want it set as a new streamline displayer. Click create and click close. And actually, you know what? I have this backwards. This new streamline displayer is the one right here. So I want to actually set that. Right click here and set this one to velocity and magnitude. And this one I actually want to switch to pressure. And you can play around with that really easily just by right clicking those. Now you'll see the effects that this has once I run the solution, and it'll actually be really great. Let's see here. So the streamline stream is actually streamline here, and that is going to be the velocity that we set. And the scalar here, the scalar field is set as the pressure. So we'll see that the effects of that as well. So let's go ahead and run the solution. And I'm going to do that by going up here to this run icon. Now it's good practice to save this before you do that in case your computer crashes. But I've already saved it. So I'm going to hit run, and it's going to pull up the residuals. And actually, you know what? Let me stop this before it gets too far. And one thing I did forget to mention is under reports here, we need to actually gather the data, and so we need to set up a report. So I'm going to right click and go to new report and go to maximum, because we're going to select, get the maximum value for velocity. And I'm also going to create a new report here, maximum for pressure. And I just renamed those, and I'm just going to right click and edit. And units, we can choose the units we want to see these in. But we have to choose our actual function first. So I'm going to choose velocity and magnitude. Click OK. So it's by default meters per second. You can change that if you wish. Click close. Right click edit and change this to pressure. Whoops, I chose this one. Pressure. Click OK. And it's in pascals. That's fine. Click OK. So now we can right-click these and create monitor and plot from report. And so when we actually run the solution, it'll come up with data for velocity and pressure. So that is great. And that goes back to what I mentioned about having everything set before you run. So click run. And it's running in the lower left-hand corner, and my residuals is populating here. And it should and it's because I started it and then I stopped it. That's why there's a point here. It should actually ground out towards 0 here eventually. And let me go ahead and open up my velocity plot. Here's velocity and pressure, and those will take a while to populate here because that's kind of compounded data. So we're just going to wait, and I'll come back to you when this is done. All right, so I've let this run, and you'll notice that I went to the mesh mode here. I just opened up mesh scene, and I actually just double-clicked on streamline to get the streamlined overlay on top of the mesh. If I go to scalar scene, you can see here the velocity of the air here, and it's actually pretty fast. So let me go under. See, let's actually go into a scalar scene. I'm gonna collapse these here. I know that we already set pressure, but I want to right click and go to new displayer, and I want to set a scalar specifically for pressure, because I believe the pressure that we set was on the outline here. So let's go into, I believe it was scalar 2 I just created. We're going to choose the parts that we want to see the effects of pressure on. Actually, I may be able to select that under here. This is kind of our default, so I'm just going to choose parts under scalar 2, the one I just created, and under that's the streamline we created, and under regions I want to select the body of the car, the front and right wings, and the rear wings. Click OK. And then we're going to need to choose a scalar field for that. So I'm going to choose pressure. So this is analyzing the effects of pressure on the car. Click pressure, click OK. And it gives you a default values that you can change. Click close, and here you can see, now if I go straight on view, obviously the effects of air pressure are going to be greatest at the cross section here of the front facing one. And so you see most of the air is hitting this ridge here, nose cone, and the rear arrow here. Now if I look back here, obviously, so we know that we set this up right because the effects of air pressure are going to affect it least based off the velocity there, because it's not hitting the rear of the car and not so much the underside. Although you will see that there is ever so slightly some pressure here at the bottom. You just spin it here. And so this is a great tool to use to analyze where the air pressure is hitting the car. And that's it for as far as the analysis goes. You can just run these reports, and it'll give you sort of the baseline that you used